Hello guys, welcome back to another virtual lab. Today we're going to be identifying compounds by their physical properties. Right, so here I created a little table on this left-hand side with the Microsoft Word document so we can record our data and figures as we go along. Right, now we're going to be using the technique of water displacement. So with that said, our materials, we're going to be needing water, of course. We will definitely need our unknown metal. Let's start with metal number one. We will be needing glassware. Okay, let's get some graduated cylinders. Let's get the largest one that we can, which would be the 50. Okay, let's get ourselves some beakers so we could place the stuff in. Let's get a 250 ml, right? And we're gonna need a scale. Okay, now that we have all our equipment, let's proceed to doing some water displacement. We will be recording our data as we go along. So first thing we're going to do is put our beaker on the scale, and then we're going to tear the scale so that the scale accounts for the weight of the beaker. We're going to add some metal in the beaker. Here it says realistic amount, okay? Let's pour. In the beaker, we have added 13.19 grams. So that is the mass of our unknown metal, 13.19 grams. Okay, good. Now we will remove that. Just place our metal in the corner. Okay, remove that from there. We won't be needing the scale anymore until we test the other one. So let's add some water in our 50 milliliter graduated cylinder. Okay. All right, let's add a little bit of water, just pour this a little bit. All right, so in here we have poured 20.94 milliliters, okay? That's our initial water volume, 20.94 mLs, okay? Now we're gonna displace the water in here by adding adding some of the metal that we had. Okay, now we're gonna add here for a little bit. Okay, so it says that we don't have enough space, but nevertheless, we have added 1.06 milliliter of metal into our thing here, into our cylinder. So now the volume has changed and the volume is now 22 milliliters, okay? That's the final volume, 22.00 ml. Okay. Now to get the final volume of the metal, we would do some basic subtraction, which would be 22.00 milliliter minus 20.94 milliliters, which would give us a figure of 1.06 mLs. Okay, that's the mass of the volume. Now, using the mass, we're gonna find the density. Of course, you know the formula for density equals mass over volume, okay? So now we have the mass and the volume of both there, mass and volume. These are the most important figures in this that we would be needing. All right, let me just highlight that there. So you could, okay. Now let's calculate the density, which would be the mass, 13.19, and we're gonna divide that by the volume, which is 1.06, and that's gonna give us a mass of 12.44, okay, per cubic meter. And if we go up here and we're gonna see what matches, and here we have 12.44, which is for our second metal, which is rhodium. So let's just write rhodium here. Sorry, spelled it wrong. So our first metal is rhodium. And now we're going to repeat this process for the other two. For the other two. And so we could get it. Let's remove this, remove that, remove this. All right, now let's add metal number two. Okay. And then we're also gonna add another glassware for this. We're gonna need another graduated cylinder for this. All right, so now the scale is already tiered. If we place this here, it's gonna be 0. Let's add some of our unknown metal number 2, pull to pour. All right, so we have added 11.31 grams of this unknown metal. 11.31 grams. There we go. Okay, this is metal number 2, by the way. Let's add in some water into our graduated cylinder once again. Add some water there. Pour. Okay, we have poured in 10.50. Okay, good. 10.50 here. 10.50 mLs. Now let's displace with the metal. We're gonna pour a metal in here again. All right, just click to pour. Okay, we have poured 0.53 into that, which gave us 11. All right, gave us a final volume of 11.00 mLs. And once again, we run some calculation, which would be 11 minus 10.50. So that's going to give us 0 0.5, 0 0.5 mLs, all right? Okay. And then calculate the density once again, which is going to be 11.31 divided by 0 0.5. That gives us 22.6. And if we would find that here, anything to match, the only matching one is the heaviest one, which would be platinum. So we could say this one is platinum. Right? And then we're gonna repeat the same process for the third metal, of course. Let's remove that. Let's remove this metal. Okay. The empty beaker. Let's add some more stuff. We're gonna add another graduated cylinder. We need that. All right. And then we're gonna add metal again. Now we're gonna go for metal number 3. Okay. Put our scale there. Same concept again. Pour out a little. All right. This time we had 11.1 grams. 11.10 grams. Okay. Let's do the water. Put the water in here. A little pour. Okay, 10.41 grams. Let's record that. 10.41 ml, sorry, milliliters. Okay. All right, now we're going to pour in our metal. There we go. And pour. We have poured 1.06 milliliter into it, and our final volume is 11.5 milliliters. Okay, and that we do our trusty calculation, which would be 11.5 milliliter minus 10.41 milliliter. That would give us all right, so that's gonna give us a value of 1.09 milliliters. So that's the estimated volume of our metal. And then we're gonna calculate for density, which is gonna be 11.10 divided by 1.09, which gives us a value of 10.18. All right. And then if we go up here, we're going to see 10.18. We have 10.5, which we could have figured out by elimination, but our final one is silver. Okay. Now let's add that into our answers here. Metal 1, we were going to say it's rhodium. Metal 2, we're going to say it's platinum. And metal 3, we're going to say it's silver. All right. Let's check out our results. And we're done. And that, guys, is how we identify metals based on their density. Thank you for watching.